Yeah, welcome to TMC. My name is Mega, and we are also going to embark on the techniques of differentiation. And one of the techniques of differentiation, once again, is called the chain rule. And the chain rule is popularly called the functions of function. It's more or less like, you know how the onions looks like. You cut an onions, and inside an onion, there is another onions, and inside another onion, there is another onions. It is also similar to a pregnant woman. That a woman is pregnant with a child, and the child is pregnant with another child, and the child inside the child is having another child inside the child. Imagine, these are children of children of children. So this is what we're going to be looking at today on that chain rule. So you can see chain rule called the function of the function. So let us assume that we have y, that y is a function of u. And you itself says, no, oh, why are you a function of me? You says, okay, me too. I am a function of something else. And you comes out to say that you says, I am a function of x. So the question is, how do we differentiate such function? It all begins with y, a mother of a variable u, and u itself is a mother of another variable x. So the derivative of the function y with respect to x, the terminal variable, is said to be equal to the derivative of y with respect to u times the derivative of u with respect to x. This is just the idea of how we can apply the chain rule to functions of functions. Now, let us look at this example now. Example, we have that y is equal to 3x squared minus 2 to the power of 3. You can see that 3x squared minus 2 is raised to the power of 3. You are having a function that is raised to the power of 3. Means that if you look at this, we usually refer to this as major function and minor function. What is the major function here? The major function here is 3x squared minus 2 raised to the power of 3. And the minor function here is just 3x squared minus 2. So we can begin. What's one of the tools that you will require in the journey of differentiation is how to understand when a function itself is bearing another function. So in this case here, we have the major function. What is the major function? The major function is the entirety of the function, while the minor function is just 3x squared minus 2. So we can begin by saying, let u be equal to 3x squared minus 2. If u is equal to 3x squared minus 2, then what becomes of y? Then we have that y, this implies that y should become u raised to the power of 3, since 3x squared minus 2 has been replaced by a variable u. So what becomes of this particular function? So you can see now that y is no longer a function of x, y is a function of u. But u tells us that, hey, I'm also a function of another variable. I'm a function, u is a function of x. So the derivative of y with respect to this independent variable can be written as the y, the u, is equal to 3u raised to the power of 3 minus 1. And that is going to give us 2. So in this case, this is what we are having now. But remember that u itself is a function of another variable. Since u is a function of another variable, how do you now differentiate it? So you have to go back by saying, but u itself is a function of another variable. So we have to differentiate u. So differentiating u, we have here to be given by du with respect to what variable here? The variable we have here is just the variable x. So we are differentiating u with respect to x. And this is going to give us, applying the power rule, this is going to give us 2 has to come down to multiply the base. So we are having here to be given by 3 times 2, x raised to the power of 2 minus 1. 2 minus 1 is going to give us 1. X raised to the power of 1 is x minus the derivative of a constant is 0. So we have it to be minus 0. So in this, we have this to be given by 6x. Therefore, we can go on to say that therefore, the derivative of y from the beginning, differentiating y with respect to this given variable x, is given by the y, the x, is equal to, according to the formula, is given by the y du times du dx. And this is equal to, the y du, the derivative of y with respect to u is 3u squared. So this is given by 3u squared times multiplied by du dx. du dx is given by 6x times 6x. When we multiply this together, 3 times 6 is going to give us 18. Letter times the letter, variable times the variable is going to give us x u raised to the power of 2. This is equal to 18x open bracket. Remember that u was an assumed variable, which is given by u is equal to 3x squared minus 2. So our final result must be in terms of the original variable that was given to us in terms of x, and not in terms of x and u. So since u is equal to 3x squared, we substitute, that's going to give us 3x raised to the power of 2 minus 2. All raised to the power of 2, all raised to the power of 2. Therefore, we have that the y, the x, is equal to 18x open bracket 3x raised to the power of 2 minus 3x squared minus 2 all raised to the power of 2. So this is how we can apply the chain rule. So just stay tuned to the next example where we can differentiate trigonometric functions and exponential functions. Thank you very much.